look at Theorem 9.3, which is talking about the probability of an event is equal to the sum of the probabilities of the disjoint outcomes making up the event, which means the overlap. What you're going to do is you're going to add up all those probabilities. So we're going to revisit the set A that's 1, 2, 3, 4, 5, 6, 7, 8. We're going to calculate the probabilities, but we're going to use the sum of the probabilities. So we want to draw an even number. So we had that we were looking at 2, 4, 6, and 8. Well, that can be thought of as the probability of 2 plus the probability of 4 plus the probability of 6 plus the probability of 8. Because these are not overlapping, they're completely disjoint from each other. So the probability of 2 is 1 out of 8. Probability of 4 is 1 out of 8. Probability of 6 is 1 out of 8. And the probability of 8 is 1 out of 8. I add these together, and that will give me 4 out of 8, which is the 1/2 that I got before by just saying, okay, there's 4 out of 8. Probability that I draw more than 5, that would be the probability of 6 plus the probability of 7 plus the probability of 8. So that's going to be a 1/8 plus 1/8 plus 1/8. So that will give me 3/8. Probability that I draw a prime number, that would be the probability of 2 plus the probability of drawing a 3 plus the probability of drawing a 5 plus the probability of drawing a 7. So that's going to be 1/8 plus 1/8 plus 1/8 plus 1/8, which is equal to 4/8 or 1/2. So again, these are looking at just adding up those probabilities. What we're looking at are things that are more mutually exclusive. They have no events in common. If two events are mutually exclusive, then the intersection is equal to 0. So for two disjoint events, the probability of their union can be shown with the following theorem. If events A and B are mutually exclusive, then the probability of A union B, this is also sometimes known as an OR, is equal to the probability of A plus the probability of B, which is what I was just doing up here, because these are disjoint, these are mutually exclusive. I can't be a 2 and I can't be a 3 at the same time, type of thing. I have no overlap. In general, the probability of the union of events such that that any two are mutually exclusive is the sum of the probabilities of those events. And we'll look at some more a little bit later. Complementary events. Basically, complementary events are the opposites of each other. One thing happens, one thing does not happen, type of thing. Two mutually exclusive events whose union is the sample space are complementary, meaning such as even or odd, head or tail. These are complements of each other. You're in one or the other type of situation. These would exhaust the entire sample space. If A is an event, then A with a line over it, that's the complement of A, is its complement, meaning all outcomes in which A does not occur. Then the probability of A plus the probability of A complement must equal 1. And then we can also do any combination of algebra on that to do some subtraction. So if you think about this, if I have, like on a die, I've got the sample space of 1, 2, 3, 4, 5, and 6. Okay? So if I think about the probability of a 2, my complement is the probability of not getting a 2. So the probability of not a 2. So the probability of getting a 2 is 1 out of 6. Not 1/2, 1 out of 6. So the probability of not getting a 2 would be everything else, 1, 3, 5, 4, 5, and 6. That would be 5 out of 6. These two things are opposites. They have to add up to equal 1. Well, if I take 1/6 plus 5/6, that is 1. And I can do any combination of 1 minus 1/6. Well, that would give me 5/6. Or 1 minus 5/6, and that would give me the 1/6. That is what a complement of probabilities is going to do. In a survey of 500 randomly selected high school students, it was determined that 420 played organized sports. What is the probability that a randomly selected student does not play organized sports? So we have the probability that they do not play sports. That's going to be equal to a 1 minus the probability that they play sports. Well, that they play sports, we have 420 out of the 500. And if I think about this, 500 minus 420, that's going to give me 80 out of the 500, which can be simplified into 4 out of 25 are not going to play sports. Same type of situation here. In reality, when a baby is born, the probability of getting a boy is 0.512. Find the probability of having a girl. Well, the probability of a girl is equal to probability of not getting a boy, it not being a boy, which is 1 minus the probability of it being a boy. So we're going to do 1 minus the 0.512. And so when we do 1 minus the 0.512, we get a 0.488. And so these items that we're looking at right here are mutually exclusive events and looking at their complements.